gotta go live. We gotta go live. We gotta go live. It's time. Welcome to another edition of RockSim Live. I am Tim Van Milligan. It is preparations for a long holiday weekend here in the United States, and my mind has already left the building. But I am still here, ready to take your RockSim questions. Hopefully you can hear me. Always have problems with the microphone. My face looks really red today on the camera. I don't know what that it's all about. We got a lot of people here. We have newtons per second from Massachusetts, Craig Kornmeyer, HPR Rocket Stuff, Space is Cool, Johan from the Netherlands. Wow. Thank you guys for all showing up. This is very, very cool. I got a monitor over here, and I got a monitor over here, and I got my laptop here. I got my water here. My mind has already left the building. Whew. Let's get started though. Let me show you my desktop. Let me bring up a new browser window here. This is the launch visualizer, but we're not ready to start that yet. I wanted to get into the Apogee website. This is our website. This is ApogeeRockets.com. If you're brand new to the live stream, if you're watching on replay, well, thanks for showing up. We do appreciate that. Like I said, we're getting ready for a long weekend. It's Memorial Day weekend here in the United States, where we honor those who have fought and died in wars for freedom of the United States. So, we do appreciate. My father was in World War II, but he didn't die, thank goodness. But so we're not honoring him, but we're honoring those that he served with that did not come home. So here we have the scrolling banner bar, and here is where you can sign up for our newsletter, which I highly recommend. We got some really good newsletters. This past week we released a newsletter where Martin showed how to take a simple rocket, something like this, and turn it into something that would be really cool in a Star Wars movie. And next week we have the start of a video series where I talk about fin fillets. Now, when I thought, well, this is going to be a simple topic, how to make a fin fillet. Just drag glue across the fin root with your finger. But it turns out to be, there's like 5 different variables to consider. And when you got more than 2 variables, it gets complicated. So it's going to be a multi-part series about everything you wanted to know about fin fillets and how to make them, which ones to choose, what materials. I don't know if it's going to be 2 parts or 3 parts, because I did the taping or the videotaping yesterday, and it was long. But I made a lot of mistakes, so some of that can be edited out. Okay. Terry Wheelock is here. Okay, we got some questions that are coming in. So if you're watching, here is our RockSim live training, which is what we're doing right now. And if you click on it, it brings you to our archive. We are on episode number 121 today. And today is May 26th. No, we're on 122 today, and 121 was last week. This is the stuff that we talked about: changing the descent rate of your recovery device, how to add motors to your RockSim, things like that. So if you're interested in all that, there's the timestamps where you can find out about them. So that's that. If you want to download RockSim, you go to How To and Guides, then you come down here to Software, and then you can download a free trial right there. Here's some tutorials. The RockSim Live Training, again, which is what we're doing now. System requirements and version history. So in general, in system requirements, it'll run under Windows 10, Windows 11 on Mac. It also runs on the latest version of Mac, so you don't have to worry about any of that. Okay, so that's the preliminaries out of the way. So let's get into some questions. So we got some questions that have come in. Alfred Indy. Okay, so he says, follow-up question on high-power rocket stuff. Is the J250 good motor to fly in the Zephyr for level 2 testing? Recommendations. Okay, so I'm in the launch visualizer, and this would be a good test for the launch visualizer. So let's select a rocket design. So the launch visualizer is RockSim in the cloud, just the simulation portion. And so we want to simulate it for flight. So you go to rocksim.com, and then you'll get this screen. You do have to log in, and I've already logged into my account. And if you don't have an account, you can make a free account. And then there's the free account where you don't log in, a free account where you log in, and then there's the paid version where you get all the bells and whistles. I am using the paid version, so I can fly high power rockets. And so when you come here, you'll see the screen and you can choose a design. And I'm looking for the level 2. So here's the level 2 rocket. And I'm going to select that, and it loads it, and you'll see it here on the screen in just a second. So this is a high power rocket, so it's using a launch rail. And this is a 3D image of the rocket. You can rotate it around and take a look at it. But we're interested in flying it. So the first thing you got to do, Alfred, is select your launch site, because the one I've selected here on my screen is where I'm going to be flying this weekend at the National Sport Launch. This is near Alamosa, Colorado. So, here's the state of Colorado, the nice rectangular state. And it's down here just north of New Mexico, right in the central part of the state. And as you can see, as I zoom in, these are crop fields, circular, with the circular irrigation. And those are huge. And this is the launch site. And you can see there's nothing around this launch site. But your launch site might be different. If you're launching near the East Coast where there's lots of trees, that's going to make a difference on what motor you select. I've already chosen this launch site. I think the wind is generally kind of like, the last time I was there, it kind of came across from the east towards the west. So I'm going to just launch straight up. So I'm going to check my starting state. It's launched straight up. And it doesn't matter which compass angle I choose, because it's still straight up, no matter which way I rotate the rocket around. Launch conditions, let's see with the wind. Let's select a steady wind. Let's make it 5 miles an hour, and making it come out of kind of like the south and the southeast. And then let's put in, he wanted a J250. So choose engine. And this is all the 54 millimeter motors, because that's what it has. And I'm scrolling down until I get to a J250, J180, 275. Where's a J250? J250. That might be a 38 millimeter motor. No, there's a FJ. FJ stands for fast blackjack. So this has a blackjack propellant, but it burns faster than the normal blackjack. So they call it fast blackjack which is what the FJ stands for. It's 54 millimeters diameter, has a burn time of 2.8 seconds. We'll select that motor, and then we have to select an ejection delay. Now this is this rocket is a dual deployment rocket, so I'm going to choose a really long delay, maybe 14 seconds. Engine overhang. The engine overhang is how far back the engine hangs out of the rocket, and for this rocket, let's make it 0.5 inches. 0.5, not 5. And hit tab and click OK. So now we've got a motor loaded. Now we've got to select our flight events, and this, like I said, is a dual deployment. Let's deploy the drogue at Apogee and the main at an altitude of, let's scroll this way, altitude of 600 feet. In fact, I am flying the level 2 tomorrow, not the Zephyr. I chose the level 2 because, like, my mind has already left the building. I should have chose the Zephyr, but it's the same thing. The question might be, can the Zephyr handle a J motor? And the answer is yes. But should you fly it on a J motor? That's the question that we're answering right now, because we want to make sure we get the rocket back. So we're going to check out where the rocket's going to land, and that's what the launch visualizer does. So I've got it set to deploy the main parachute at 600 feet, and it's a 58-inch parachute. And then I'm just going to launch, and it's going to simulate using 708 credits. That's how many Newton seconds are in a J250 fast blackjack. Okay, so there's the rocket sitting on the pad, and if I zoom out a little bit, you can kind of get the lay of the land. This is a really, really nice field for launch because there's no trees around here. So that's where I am going to launch, and I'll just click launch, and the rocket just took off from right there. This is the smoke trail coming out of the rocket. You get a larger view right here. We call this the mini view. Just kind of shows the rocket taking off. When it gets to Apogee, the small parachute should pop out, and it did. The rocket reoriented itself, and now it's at 3,100 feet and falling, and it's going to take a while to get down to 600 feet, but when we get down to 600 feet, the main parachute will come out. While it's doing that, I'm going to turn on the trajectory and click OK, so we can kind of see it coming down. Down here is the ground path. So it arced into the wind a little bit, but now it's coming back towards the pad. Man, it's going to be really close to the pad. Okay, so we're below 600 feet now. So the main parachute did come out, and you can see as it was coming down on this path, it changed direction because the big parachute is now allowing it to drift a little bit more with the wind. But it's not going to be drifting very far. This is going to be close to the pad recovery, so I'm going to pause it right when it gets to the end. Oops, all right, it took off again. All right, so the rocket is down on the ground. I'm just rotating it around to kind of see north. North is the black arrow, so that's pointed to the top of the screen. And you can see it went pretty high. Oops. I lost the rocket. Click on the home button if you ever lose the rocket, and it will bring you back to the launch pad. So there's the launch pad, and this red line here is the trajectory, and then here's the rocket sitting down on the ground, and there's the parachute out. So it did not land too far from the pad. It only landed 71 feet away. So this rocket, I would say, is okay on this field, but you do want to check your wind conditions. Like I just estimated my wind at 5 miles an hour. coming out of that direction, depending on your field. So check that out, Alfred, when you're choosing motors. Okay, so that answers the first question. We have Carlos from Marietta, Georgia here. Thank you, Carlos, for showing up. Okay, and Alfred asks a launch visualizer question. On the wind table, do you add the above sea level figure to each added wind level? Okay, so in the launch visualizer, so we're going to add a custom wind table. So on this first simulation, what I did was I chose a steady wind at all altitudes. Now it is possible that you have different wind speed at different altitudes above the ground. So first, let me see my launch site. My launch site is 7715 feet above sea level. That's what ASL means. So this rocket is already, we're in the mountains here in Colorado, and this is a high valley. So bring your oxygen. Under launch conditions, come over here, and we're going to choose a variable direction wind table. So this is what Alfred is talking about. So our current rocket altitude is 7715 feet above sea level. And so now we're going to add new wind. And so, but notice here, the altitudes that you put in are always above sea level. They're not measured above ground level. So if I put in a wind direction, so the wind direction is compass direction. So if the wind is coming out of the north, it would be 0 degrees. If it was coming out of the east, it would be 90. 180 degrees would mean the wind is coming from the south, and 270 means the wind is coming from the west. So if I say my wind is coming out of the west, which is the 270 direction at 10 miles an hour, but if I leave this at 0 feet, what that means is this rocket is never going to feel that wind, because that wind is below the ground, because I'm already starting at 7715 feet. So ideally, you would start this one at 7715 feet at 10 miles an hour. And then you go up from there. So let's add 1,000 feet. So I'm going to add a new table entry, and I'm going to add 1,000 feet to that. So 8715, and let's make the direction 280. So just like a swinging of 10 degrees, and let's make the wind 15 miles an hour. So as we're going up higher, we got a shear layer there, and it's blowing a little bit faster. And I can add a couple of more. Let's add another 1,000 feet, so that's 9715, and let's make it from the 0 direction. So now it's blowing out of the north, and let's say it's 25 miles an hour. And we'll give this wind table a name. I don't know what we want to call it. Shear winds, and I'm going to save this wind table into my database. Okay, so it told me it's saved, and if I choose a wind table, I should see, I got 3 of them in here already, and this is the one that I just made. So you can select that, and it shows them. If you want to select a different one, you can choose a wind table, and I can say let's choose a swirling wind. If I look at this one, this swirling wind table, all these altitudes are below my launch altitude, where I'm starting from. So this rocket would never see any of these winds. If the rocket took off with this wind table, it's like there's no wind blowing at all. So let me choose my other one. That was the shear winds. Click OK, and you can see it repopulated them to now we have different winds. I can click OK, and let's launch the rocket again. And we'll add shear winds as a comment and simulate. And remember our previous trajectory, the rocket landed pretty close to the pad. And where is it? That's the old one. Stop. Why didn't it display this one? Rerun that one. Let's see what happens. Okay, let's see. Rocket takes off. See, it's wiggling a little bit. That was kind of cool. It's reacting to the wind. And it's arcing over. Let's zoom out a little bit. So I'm going to choose the trajectory view right here, and it will give me kind of a different perspective on this launch. And okay, so now the rocket is coming down. Let's swing it around so that the north is this way. I don't think this is the right wind table, because the wind, I can kind of see that the rocket arced this way just like it did the last time. So this did not run. So I'm going to cancel out of that. I'm going to run it again. Just double check, make sure I got my, okay, I'm using a variable wind direction. I'm going to click launch and then simulate. And it better work this time. And it didn't work. Okay, I got to talk to my programmers. Yeah, see, there's no new simulation here. That we should be on simulation 126. Huh! Let's change the motor. See if that makes a difference. There was another J250. It was a Hypertech. Okay, and launch and simulate. Let's see if it works this time. There's something going on with the wind table, because the only thing that we changed was the wind table. Variable direction wind table. Let's go back to steady wind. Let's swing the wind out from a different direction so that we can get a different perspective, just to make sure that it's working. We may have discovered a bug. Thank you, Alfred. Let me go to trajectory view. So the rocket's right in there. I noticed this is a different number. Before it was like 76. And it's going really high. It's not arcing into the wind hardly at all. Well, yeah, it is. I can see that red line that's starting to display there. That's the ground path of the rocket. It's coming down. I want to speed this up, get it to the end. Yeah, it's still landing pretty close to the pad. 156 feet, so it's a little bit further than the last one. Yeah. So I don't know why the wind did not work. My variable wind table. That's strange. I think I'm going to have to look into that. Because all we did was choose a variable direction wind table, and we chose a wind table, this one right here, and all that looks normal. Click OK and launch, simulate. Yeah, it didn't display my simulation. Oh! As always, discovering bugs. Right, we're in the middle of the live presentation. Okay. So, hopefully I answered that question. See, now, if we were in RockSim Pro, it'd be the same. So here I have RockSim Pro. Let's try that in RockSim Pro just to make sure. Here's a Zephyr. We're gonna run the Zephyr anyway, Alfred. Do I want to save my changes? No. So in RockSim Pro, this is very similar to RockSim. To select the motor, hit Prepare for Launch, then choose the engine, and we're going to scroll down until we get to the J's, and we're looking for a J250. If there is a J250 in 38 millimeter, we got a J270. I'm not seeing a J. Got a J520, but not a J250. So we'll choose the J270 and make it a 14-second delay. Engine overhang of 0.5 inches as before. Starting state, deploy parachute at maximum ejection delay. Starting state, we're going to need to make this a little longer, 98 inches long for a launch rod. Let's go straight up. Launch conditions. This is the same field in Alamosa. Wind table. Okay, so here is, again, it's above sea level. Our first wind, I'm going to make a new wind table. So our first one is 77.15 coming out at 4. Let's change it. Let's make it a little higher winds. This is at 40,000 feet. Let's make it 25 miles an hour, and the direction is 359. So that's pretty close to almost north. 360 would be north again, or 0. Then we hit flight profile. We're launching, and it's opening up the launch visualizer that's built into RockSim Pro. So there is the Zephyr sitting on the launch pad, pretty much the same location we were before. So it's right in the middle of the screen. We launch. Rocket takes off, goes nice and high. This one's going a lot higher because it weighs less than the level 2 kit. So that's the other thing, you know, when you're launching a lightweight rocket with a big J motor, they're going to go really high. And the rocket is coming down. Let's go to a trajectory view. Let's turn on our display trajectory path and make it green. And I don't need to see the intervals. Okay, so where's the rocket right now? If you lose the rocket, just hit the where's the rocket button. It says the rocket is right in there somewhere. Oops, the rocket moved. There it is, and it's still moving. It's falling down. I can't keep up. So here was the launch point right there. No, right here. The rocket arced into the wind. Oops, I'm going the wrong direction. It arced into the wind. And now it's drifting down to the ground. And I'm just moving it along, making it faster. And if you notice, if you look closely, this line right here, this is like the ground path. It looks straight, but it's actually got a slight curve to it. And that's because of our variable wind. At 40,000 feet, it was coming out of the north, but lower down to the ground, it was coming out, I think, out of the southwest. Let's see. If I spin north around. Okay, so now the north is up here. So our wind near the ground is blowing this direction. And that's why it's going over here. So again, see on the J motor, the rocket is landing 3,500 feet away. So that's more than a half a mile away. On this particular launch field, it's not a problem. This has got wide open spaces. We're not going to have any problems getting this back. So on this particular field, I would have no problem flying a J motor. But if you have a smaller field, yeah, that's something you better watch out for. Craig Kornmeyer says, so in RockSim 10, 2D flight, my two-stage rocket wiggles as it leaves the pad. Why is this? Okay, so let's open up RockSim just so that we're showing RockSim. I'm going to close the launch visualizer. I think we're done with it for today. Where's RockSim? RockSim 10 right here. I'll open this up. He's flying a two-stage rocket. So let's open up a two-stage rocket. And this doesn't, it could be any rocket. It's just, it's not particular to two-stage. I know exactly what's happening. So here's the rocket kit called the Skymetra. It's an Apogee kit. It's a two-stage rocket. And let's load engines into this. So we have the this one right here is the upper stage, and this is the lower stage. So let's choose, let's put in Estes C6 motors in both stages. And I loaded it into the upper stage as a C60. But we're going to change that ejection delay in just a second. I just want to show you the quick way to load engines of the same size in motor mounts that have the same diameter. So you just highlight the one that you just loaded, and then you just hit load all. And I just loaded that C6 in the bottom stage as well. And then I can choose my ejection delays on individual stages. So on the upper stage, let's make it a C6-7. Which is okay. Flight events, deploy the parachute at maximum ejection delay. Simulation controls, I leave that alone. Starting state, let's make it a 36-inch launch rod. And we'll launch it straight up under launch conditions. On my first launch, I'm going to change the wind to 0. Okay, so now we're launching straight up with no wind at all. All right, and when we go to the flight profile, so here's the rocket sitting down here, and what he is saying is he's noticing some wiggling. So when we launch, and now this has 0 wind, what's happening is, I mean, this thing is rock solid. There's no wiggling at all, and that's with 0 wind. So basically, the rocket is just going straight up. So let's change the simulation, and let's add wind to this. So we're going to again go to prepare for launch, and this time under launch conditions, let's add an 8-mile-an-hour wind. So I got a custom speed range. Custom means that I can set. Custom means it's like when you're out on a launch field. Sometimes a gust of wind will come through. So sometimes it might be a low wind, like 3 or 4 miles an hour, and then sometimes it might be 8 miles an hour. And so that's what this means. I got a low wind speed and a high wind speed. But if I set them both exactly the same, it's kind of like just a constant wind speed blowing through at any given time. So I got 8 miles an hour constant wind blowing through, and that's how you get a constant wind blowing in RockSim. Okay, so now the only thing I changed is I got an 8-mile-an-hour wind. Let's go look at the flight profile. Okay, so the rocket is right here, and if we launch it, okay, so did you see the wiggle? It wiggled like this. It snapped back and forth. Let me replay that again. So right here, as it comes off the launch pad, watch that rocket. It's gonna do like that, just a little bit. And what it's doing is it's reacting to the wind. So the rocket's taking off, a gust of wind hits it, and it pushes it this way. But the rocket's fins are going to start producing lift because the rocket's flying at an angle of attack. And the lift is going to come in, like, basically in the same direction that the wind was blowing, and it's going to pull the rocket back around. And so what happens is the rocket tilts into the wind and then comes back around, but the rocket overshoots because it has momentum. Momentum, you know, is velocity that remains. You know, it's inertia. It's one of Newton's laws, where a body in motion will remain in motion, and so once it starts moving backward, it's going to remain in motion until another force hits it. Well, as it comes back past the wind is now going to create a lift in the opposite direction, and so it tries to straighten out, and eventually it's going to wiggle back and forth, but each wiggle is smaller and smaller and smaller until the rocket actually straightens out and goes into the wind. So that's what you're seeing there as the rocket's wiggling. And you can see that better if you go to the graphs. And so I'm going to go to the graphs, and I'm going to say what I'm going to look at is the wind angle of attack. Right here, wind angle of attack, and let me clear out these other ones. So let's plot this graph from time 0 to apogee. Okay, and then let's plot it, and you can see the rocket wiggling. Let's see if I can make this bigger for you. And so as the rocket is on the launch rod, it's not wiggling at all. So the wind angle of attack while it's on the launch rod is 0 because the launch rod is holding it in a fixed position. But as soon as it clears the launch rod, now we have an angle of attack. And so what the rocket does is it responds to the new angle of attack, and it points the rocket into the wind. So it changes direction, and it overshoots, and then you get a lift force in the opposite direction, and so then it turns again into the other direction, and it's going to do that until eventually it dampens out and it finds a nice, it wants to fly into the wind. This is called weathercocking, and all rockets do this. And it's actually a good thing. It means your rocket is stable. We want to see this. If your rocket does not do this, it means you're unstable. The rocket is unstable, not that you're unstable. So I can force it to do that by moving the center of gravity. So let's put a mass object in this rocket and move the center of gravity right where it's right here, back behind the center of pressure. So I'm going to go to the design components, and I'm going to go on my booster stage. So I'm going to put my mass object in the booster stage. I'm going to add a mass object. That's the database. I'm going to cancel out of the database because I want to edit it directly. So it's showing it right here at the front of the booster motor. I'm going to move it all the way to the back end, and I'm going to give it some mass. And as I give it mass, watch the position of the center of gravity change. So if I gave it, 20 grams, hopefully you can see that. It moved. It's still in front of the center of pressure. So the rocket is still stable, but if I add maybe like 5 more grams, now we're unstable. And you can see that we're here, it's unstable. So if I click OK, and that's the only thing I did, is I just added weight to the back of the rocket to make it unstable. And if we launch it again and hit the flight profile, it might go unstable. Let's see. Yeah, it did go unstable. It did not like having the center of gravity behind. Let's look at that 2D graph again. Same thing. Let's change the flight time to, I don't know, 4 seconds, so that the graph is a little bit bigger. Yeah. So here is the rocket taking off on the launch rod right here. It leaves the launch rod, and it never swung back around to try to point into the wind. It just got really crazy. It probably did a flip. This is probably the rocket doing a series of flips until it finally hits the ground down here. Not a good situation. So that's what that wiggle means, as the rocket is that you see in the 2D flight profile. Newton's Terry Wheelock says, can we build a balloon launch rocket? The answer is not in RockSim, but in RockSim Pro you can. Or in the launch visualizer, you can launch your rocket from a balloon. So again, here before we had this rocket, and we launched it from the ground, and the ground elevation was 7,700 feet. But if you launch the rocket from a balloon, to do that in RockSim Pro or the launch visualizer, you go to your starting state tab, and you'll see down here, that's under launch conditions. Our starting altitude, let's launch it from 13,000 feet. And this is above sea level. So this is, 600 feet or 6,000 feet above the ground altitude. And if we hit the flight profile, our rocket, our launch pad, it'll still have a launch pad, but the launch pad is no longer resting on the ground. And if I zoom out, where's my rocket? I think it's, let me launch it and we'll see where the smoke is. Okay, let me pause it right there. I lost my rocket. Let me go to the trajectory view because it's easier to find the rocket. Okay, so there's the rocket, and this is not on the ground. This is actually in the air. You can see that the rocket, so I'm starting in the sky right now. And when we launch the rocket, so the rocket is already going, and we'll continue the launch. It goes really high because we're starting really high. I lost the rocket again. There it goes. It's way up there. Let me turn on the trajectory path so we can see it. And the rocket started there. I got to zoom out to find my rocket. So there it is, right up there. And I'm going to speed it up and see where it comes down. Okay, so it landed. It landed in this crop circle right there. So our launch point was in the air right there. The rocket went high, and then it had to come back all the way down to the ground. RockSim Pro can do this, and the launch visualizer can do this, but you can't do it in RockSim. but that's fun. Newtons per second asks, are you coming out with any new RockSim stickers? It's not on our plate right now, but you never know. You never know. HPR Rocket Stuffs, will Apogee design any 7.5-inch wide rocket kits? Well, we can design them all day long, but your question is probably, are we going to produce any 7.5-inch kits? And the answer to that is not yet. The reason is we don't make our own 7.5-inch nose cone. And without a nose cone, it's really hard to make the rest of the rocket. Because we would have nothing to give to the customers. I would like to do a big rocket someday. We've been thinking about it. The problem that we have is shipping. It's like when rockets get really big, the shipping goes astronomical. And we have to find out, are customers willing to pay a lot in shipping? And we hear all the time that people don't want to pay any shipping. You know, they want it to be like Amazon Prime, where it doesn't cost any money. The unfortunate thing is we are not Amazon Prime. We have to pay the shipping rates. And you know, if we included the shipping in the cost of the kit gets really expensive. There's a lot to do to make a high power kit that big in diameter. It's not, we're thinking about it, but we haven't pulled the trigger on anything yet. Fatbank says, does RockSim consider the weight of the booster or the total weight of a two-stage rocket when sizing a parachute for booster recovery? Okay, let's take a look. I don't know the answer, so let's find out. So we'll go back into RockSim. We have our two-stage rocket. Let's pull that mass object out. So I'm going to go to the rocket design components, and I'm going to pull that out just so that we get rid of it. So delete that. Say yes. Let's put a parachute into that booster tube. So here's the booster stage tube. I'm going to put a small parachute into this. Why did I enter? I double clicked. I wanted to select it and then hit parachute. And let's put in a 12-inch plastic parachute. And let's cancel first before I do that. So right now, the calculated descent mass is 29.753 grams. So the question is this the calculated descent mass of just the booster stage or the upper stage? And we need to figure that out. So how do we figure that out? I'm thinking just because the mass is so low compared to the overall mass of the rocket down here of 93 grams, that this calculated descent mass is just the booster stage alone. So let's find out. So I'm going to cancel out of this. Save my changes? No. I want to take this tube right here, and I'm going to do a copy. So I'm going to do a right click, hit copy, and now what I'm going to do is I'm going to start a brand new rocket design, and it's just going to be the booster stage. So create a new design file. Do I want to save this one? I'm going to say no. And it should crash. It crashed. I hope it remembered what I had copied to my clipboard. So under rocket design components, let's do edit, paste, and it didn't take. Let's try this again. That was the Skymetra. Let's see if we can get it crashing again. Let's go to the booster stage, copy that, go to File, New. I think it's going to crash again. Let's try something different. Okay, File, Open, Skymetra. Okay, and then I had a question before, is can you open up RockSim twice? And I think the answer was yes. So, but we need to go to, let's go File, Open. Let's see if it opens up a new instance. And it did. Did you see what I did there? I had RockSim open, and I went to my shortcut, which was on my desktop, and I did a right click on that, and I said open. And it opened up RockSim twice. So now let's go to the first one. Let's do what we did before. Select this, copy it. Now go to this one and go to Sustainer and then do File, Paste. It worked! Okay, so now let's add a parachute. Isn't that cool? I'm learning this too. As you and I are working on this right now, I'm learning things. One, I learned I could crash RockSim, and I got to contact the programmer about that as well. And then I learned I could open up a second instance of RockSim, so both of them are running at the same time. And then we're going to add a parachute to that body tube. And we're going to add a 12-inch, cancel out of this. Cancel. So I'm in it's telling me my calculated descent mass is 17 grams, which before it was 29. But the difference here is we don't have a rocket motor. So let me cancel out of this. Let's put a rocket motor in here. And I think we had C6s in here. C6, click OK. Doesn't really matter the delay, just click OK. And now we're up to 40 grams. And now let's add a parachute. Cancel out of the database, and we're back to 29.75 grams. So that answers the question. So the question he asked, does RockSim consider the weight of the booster or the total weight of the two-stage rocket when sizing a parachute for booster recovery? And we just found out that this calculated mass when you're on the booster stage is just the booster alone. So let me cancel out of here. Let me go back to our two-stage rocket. And so if I go to the booster stage and I add a parachute and I cancel out of the database, I don't have a motor in here. Let's load motors. Choose an engine. C6, that doesn't matter what the delay is. Load all. We'll make that a C6-7 in the upper stage. Click OK. Okay, so now if I add a parachute to this booster stage, remember when you're sizing your parachute, we talked about this last week. When you're sizing a parachute, always put in the rocket motor, because RockSim is going to see the motor in there and it's going to subtract out the propellant weight of the motor. So the calculated descent mass of the booster stage alone is 29.75 grams. And if I put in an 8-inch parachute here, give it some thickness and give it some shroud line. I'm looking for cotton thread, carpet string, Apogee shroud line length. Let's make it 8 inches. Okay, so now our descent mass changed. And why did it change? Well, because we have a parachute in there. And so we have to account for that mass of the parachute. And the mass of the parachute is here, 0.402 grams. And our descent rate on this parachute is 10.95 feet or miles per hour. As a comparison, if you selected the preset rates of low, so 10 miles an hour is faster than 7.8, and it's closer to the high descent rate. So this parachute is at 8 inches is probably on the small side for this booster stage. If I selected a medium descent rate, medium means around 8.9 miles per hour, or in feet per second, that's around 13 feet per second, or in meters per second. I'm looking for a nice whole number. There it is, the nice whole number. 4 meters per second is about the medium descent rate. And to get that descent rate, we need a parachute that's 9.79 inches in diameter. And you'll probably just round that up to an equal 10-inch parachute. So that is the size of the parachute I would need for that booster stage. And so when you're putting that parachute in the booster stage, RockSim is doing it right. I thought it was, but I had to confirm it, and we did confirm. Craig says, Tim, you're the best. Thank you, Craig. Tell my kids that. Johan says, yeah, Tim has made an uneducated mistake. He gave me RockSim for free. I could have come up with so many great questions. Cool. Johan said, Tim's drinking strange water again. Must be Colorado water. It is Colorado water, but Colorado water is some of the purest water around because it's strictly from the snow. You've heard that phrase that says, as pure as the wind-driven snow. As the snow comes down, it's distilled water until it hits the ground, and then as it washes down river, it's not like groundwater where you're pumping up anything that's in the ground, all the pollutants that are in the ground. This is snow melt on the mountains. Our reservoir is over 12,000 feet high in the mountains, so there's it's not low water, and so it's pure water, and then they filter it after that, and it's so Colorado water. I'm sure you've seen the commercials for Coors beer, and they tout how great the water is that goes into the beer, and it is good water. So anyway, but it doesn't have that strange marijuana stuff in it that Colorado is also famous for. Craig says, Tim, you're overall outstanding, over and beyond. Cool. And Alfred Indy says, it sounds like a Coors beer commercial. And it is a Coors beer commercial. Johan says, we drink 10,000-year-old groundwater from 120 meters deep. He's in the Netherlands, so he's below sea level. So anyway, that is so cool. And it is now very close to 3 o'clock, so we're going to call it a day. because as I said, my mind has left the building. But we've learned a lot this week. We've learned how to open up a second instance of RockSim, so you can copy and paste from one instance to the other, just to figure things out. We've learned how to crash RockSim. We've learned that the launch visualizer has a bug. We talked about parachutes. We talked about how to pick rocket motors for the Zephyr, for the Level 2. Yeah, we did a lot today. So thank you for coming. We will be back next week. We'll be in the month of June, I'm sure. What will be the date? I have to check my calendar here. Gotta check my calendar. It will be June 2nd. And I plan on being here, so we'll see you at the same time, the same place, RockSim Live, here on YouTube. You can always watch it on replay, but it's so much more fun when we're live. And thank you all for coming. You guys are really good with questions, and I appreciate them. And we'll see you next week. So in 5, 4, 3, 2,